All right, here's your hint for number one. We have ourselves a pendulum problem. I understand it is Tarzan on a vine, but he is essentially a pendulum. And so to find the height so that we can plug it into potential energy, we need to do a couple more steps first. So they gave us the length of the vine, the angle it starts at, and then the angle it ends at, so we can get a height before and a height after. And how we find this height is we say, okay, this length is 8L, this length is L. This little triangle I can make here has a side L cosine theta. So the height is going to be the length of the vine minus that L cosine theta will give us the height. And so we can write it like that, or we can factor out the L. This will give us the height given the length of the pendulum and the angle it makes with the vertical. Now, for what's going to cross out for us for this Tarzan problem. So no one is pushing on Tarzan as he goes across the vine. There's no air resistance. He does have kinetic energy at the end, and inside that kinetic energy is the velocity we are trying to find. There is no kinetic energy at the start. He does have a height at the end and at the start because everything is comparing the height relative to this being a zero height. Okay? And there is no springs involved in this situation. And so when we start to make those substitutions, again, we're going to have 0 equals, and we'll make our substitution 1/2 mv squared plus, I got mgh2 minus mgh1. You'll notice all of those masses cancel, so we did not need to know the mass of Tarzan. And this is the velocity we're trying to find, and the two heights we find using our pendulum stuff.